Okay, it's now time for HTTP. So, what does HTTP stand for? Anybody?
Hypertext Transfer Protocol.
Yeah, Hypertext Transfer Protocol. So, that should sound very familiar. HTML.
What do TCP and HTTP have in common?
The protocols.
P.
Protocols. So, HTTP is a protocol on top of TCP. And it's a plain text protocol. It's actually pretty simple. And it's completely described in this document. RFC request for comments. You can find lots of definitions of protocols here. And this one, it's all plain text, which is kind of funny. But you can read through it in great detail.
That is funny.
You'd think it'd be in HTML, given that it's HTTP protocol. But so, what does HTTP look like? So what it looks like is described here, but I'm going to show you by making the server, and we'll see it. I want to reinforce this idea that it's just a TCP. It's just on top of TCP. So I'm going to make HTTP-example and make a main go. We'll just copy rot 13 here. And so instead of doing this copy bit here, what we're going to do is make a scanner, hand it a connection, and then loop over every line and just print them out. So we can see what happens when our browser hits our TCP server. Okay? And that way we can see the protocol. So I'm listening on port 9000 like we've been doing. So kill the chat server, go to HTTP example, go install. So now I'm running my server. If I go to my browser and hit localhost 9000, okay. I misspelled localhost. Localhost, that's not right. Okay, now we see something. So this text is what my browser sent to my server. Notice this is just a text protocol. It's really easy to read because it's just plain text. So an HTTP request starts with this line. Get a space, then the URL, a space, and then HTTP is the protocol version. So if I change this to go to some other URL, we will see that this changed here, right? So it's just passing through what I passed up there. Then all these other things are called headers. And so headers, they have the colon, right? And this is the header key or header name and the header value. So the host here is set to whatever I typed in. And then the connection key alive, we'll talk about what that means. And all these other things have various meanings. And so that's the protocol. And the idea is that we receive requests in that protocol, and then we send back responses. And the protocol also defines what the response is supposed to look like, okay? And we can get something of the idea of that using Wireshark or similar, but I think if we just look at the net tab, we may be able to see it. Well, it's just going to show the plain text, so it's not going to show all the response headers. There's a way to do the curl. Does anybody remember the?
Dash I.
Okay, curl-I and say google.com.
Yeah.
There we go. So the server responds with a version and then a status code. So 200 would mean okay and everything's great. This one means it's a redirect, and it's just redirecting you to www.google.com. So let's see if I go to there instead. Now we see a lot more stuff. So they get 200 okay. So the status code, that's defined in that document, what those status codes mean. And you're probably familiar with some. Have you ever heard of 404? It means not found. So that's what this code is. You've probably seen your browser show you that before.
Your pref ID is interesting on that, just out of curiosity, right? Like, what? It's all a bunch of ones. I'm sorry, scroll down a little. You either like have a really low preference to Google or a really high.
Yeah, I don't know what that cookie's for. So So does everybody understand what I'm getting at here? We make a TCP server. We made one, and we're reading line by line the protocol. And the idea is that we can speak HTTP in TCP. And the format, the basic format is a request line. The request line looks like the method, which is get, post, put, or I listed them down somewhere here. Get, post, put, delete, head. And then the request URI, that was the /some/other URL, whatever. If you just go to the root of the server, it's just slash, and a space, and then the version, and then a new line. New line's always /r/n. Okay. So it's the Windows style new lines with the 2 characters. And then followed by, so we have the request line, and this just means one or more headers. And so what's a header? A header is name, value. So you have a bunch of those and then a blank line. So that just means there's nothing before this, right? So we have the request line, a new line, a bunch of headers, each separated by new lines, and then a blank line, and then a body. And this is what we're sending to the server.
So tell me curl F.
Sorry.
That's a new line, I can see that, but where does CRLF come from?
LF is a line feed, CR is a
carriage return.
Carriage return. That's the word.
Carriage return line.
So it's the 2 characters. And this I copied from the document. That's all it's talking about. And then so there's a message body. For a get, there's no message body. For a post, we post data to the server, and so then there would be a message body. And that data would be stuff that's in a form, for example, or if we're uploading a file. Okay. And we'll look at the format of that later. But the basic idea is that for gets, there's no message body. For a post, there is a message body. That's why it's in the brackets, indicating it's optional. And then the server is going to respond, and the way the response looks is it has an HTTP version that's very similar to this guy. And then you have status code 200, 404, 30, whatever. And then the reason, which says OK or not found or whatever. And then a new line. And then we go back here and we have headers again. So the request and response look very similar. Okay? And so for us to make an HTTP server, what we have to do is parse the request and respond with the response. So I have not prepared this example, so I'm going to do it just making it up. So this may take a few tries to get right. But
I'm going to just put that over to scratch because I like the way you got the header to show up there. I'd like to look at that later. Thank you.
I'll leave the print line in there so we can see it. So let's just try to get one request and one response. So I'm going to change this for into an if. Well, we'll do it like this. So I'm just going to increment this each time. Okay, so if I is 0, that means we're the first row. So we want to get the method, say. We can get the method by saying, you know, strings.fields, give it the line, and go 0. That's going to get the first bit. I'm going to get part of it. So let's print that and see what we get. I'm just going to use curl instead of the browser, so I'm just going to say curl localhost :9000, just because it's faster than having to go to the browser. But it does the same thing. It just makes the same kind of request. Okay. And so we got the get there. I forgot to rebuild, so I didn't. There we go. So I got method get. So I know what method I have. And I pulled in all the, so now what I need to do, that's if I is 0 and then else. So this first if here is I'm looking for the method, the request line, and now I'm in the headers. So in headers now. And so how do I know when the headers are done? Empty line, blank line. That'll tell me my headers are done. So if line is empty, then I can break, because my loop's done. I've parsed the request. That works for get. It wouldn't work for a post because then there'd be data. But for get, that works. Okay. So if line is that, and say and method is get. But we don't have to do that. We can just treat it like that for now. And so now that's how I can know I'm out of the headers, right? And so now if I wanted to respond, I have to format my response in the format that it wants, right? And so we saw from this example, that's the format. So I'm just going to put that. I'm going to send that to connection, right? You can use .writeString, or we can use format.fprintline, but we'll use write string.
We both take a writer.
Yep, con, and then /r/n, remember the control line feed.
And con implements the write method, which is why.
So it's like a file, so I can write to it. Okay, and then what else do we need for the response? We need these headers, right?
Just highlight where those headers are again. Where?
So when you communicate on the web, like there's a standard for web servers, HTTP servers, and they have to conform to certain standards. And so one of them is when a request comes in, the request has to look like this. And so he was kind of looking at like the docs, where this is what the request looks like, and when a response goes out, the response has to look like this. So it's just, everybody has to conform to this when you put together a server. And so you can see that by, looking in certain areas. Let me see the request, let me see the response. It's in the header information. So you get the web page, but something you don't normally see as a user is there's this header info, where you make a request and this header info goes with it. Does that answer your question?
Yeah, I was just trying to see where exactly in the code, in his thing that the header part is what's considered the header part.
Let me show it here. Okay, so I found a GET request, and it has within it hypertext data, and it breaks up, it shows me the data in a nice format in this Wireshark. In Windows, you can use a program called Fiddler, like Fiddler, which is much better for this. There's no equivalent in OS X, so it's one of the rare circumstances where the tool in Windows is far superior to anything outside of it. So, Fiddler. What it does is it will intercept all HTTP traffic on your machine, and then you can inspect it, which makes it easier.
So that's better than Wireshark?
Well, Wireshark's lower level. So the nice thing about Fiddler is it's easier to use. This is like hard to use because it's so much information. But we can see here the full request, right? So it had started with get, and then it has host and all this other stuff. One of these things is content link, but I think it's using. Look at the wrong one here. Well, there's sort of two options we have. I can't see it very well here. We can give it a content length and then send the data along with it. So suppose I just want to respond with the word test, okay? And we can say write string con, and I'm going to say content length 4, because test has 4 letters in it, /r/n. And then I'm going to write that to the connection. First I have to write a blank line though.
And the R is the character return, and N is the line feed?
Yeah. Okay, let's see if this works. So what I've done is I created the response status line. I just copied that from the other example. Then I added one header, content-length, gave it a number. Then I had a blank line and then the body. So let's see what happens.
Hard coding the length because the body is 4 characters.
Right. So let's see what if I run that. And then I say curl localhost 9000. There we go. So it gave me that kind of test. Let's look at that in the browser just so we can see that it works there too. Right?
While you bring that up, what would happen if you had a server that didn't conform to the spec for how servers are supposed to You know,
It depends on how it didn't conform. Because this is HTTP, we start to enter the realm of things are very forgiving. So for example, if you just use regular new lines, it may just work, even though you didn't meet the spec, because browsers are very forgiving.
Okay.
Because in the early days of the web, people, like, things were thrown together haphazardly. And so, for example, if you leave out closing tags in HTML, things just work. Even though that's not according to the spec, they're very forgiving. Which is nice if you're trying to learn things, because you can make a mistake and it doesn't, it just works. So this worked, right? I got test in the browser. So let's abstract this a little. And now we want to make a body, and I'm just going to say hello world. And instead of having the 4 hard-coded here, we'll use fprintf, and then I'll pass in the length of the body. And then instead of printing test here, I'll print the body. And now I can change the body, and it would change the response appropriately. So let's see if that works. Hello world, right? If I change that, then theoretically, that's how it works. It should update. Hello world 2, okay? Everybody following the idea here?
Yeah.
So, I mean, this is a really clunky way to build an HTTP server. I'm just showing that you can build it purely from TCP. And I could do different things based on the method. I could do different things based on the URL. I could do different things, because I can get the URL. How do I get the URL from here? Do you guys remember the format?
How do you get the URL?
So remember, it comes in as get, or it's all caps, right?
So it would be the second one. It'd be
Exactly.
The second.
Because it comes through as get,
21.
URL.
Be length 1. Fields ln1.
That's exactly right. So we get fields at 1, right? So f, say, at 1 would give me this. So we could, pull that into a variable and switch on it and do different things based on different URLs, right? We did that example earlier with the conversion functions and stuff. Very similar idea. So we can build an entire HTTP server just this way, if we want.
And that's how we start doing our request routing.
Yeah. Using a switch statement or something. Or a map.
Can you copy that code over too, please, Caleb? Thank you.
Is everybody following this example? Is somebody completely lost here what we're doing? So yeah, we read in the request, and then we write out the response. That's the idea. Now, the issue with this is actually, we probably need to put a connection close, or just close the connection, because right now it keeps it open, and the way the browser works is it can send another request over the same connection. And so right now we're not going to be reading that next request. We're just sort of skipping it. So, I mean, I guess we close it here, so maybe it doesn't matter. But normally you would do this in a for loop, basically. So I'd read the request, do the response, read the next request, do the response, read the next request. But this still works for one request. Okay, so I think we have a problem that we can do. Let me make sure that's true. I already did this for you. Create a TCP server which can handle a simple HTTP request and return hello world. So let's change this to create a TCP server which can handle a simple HTTP request and return the URL that was passed into it. So what I want to see is that over here, instead of saying hello world 2, if I go to / some other URL, I see / some other URL. I want to see whatever is passed into it, okay? Everybody understand that? No? That's,
Yeah, I understand.
okay? So I think with this program as a base, you should be able to write that program.
And that's
okay?
on GitHub and then also Scratch.
It's in
do
Scratch.
so it's on Scratch too. Could you speak for one moment about using for loops as listeners? I've heard somebody talk about that before, like, hey, you just do this infinite loop, and that's a listener. And I can see it seems like you're kind of doing that, and that's my terminology I'm putting on top of it, right? But like, if I need something to always be listening for input, it looks like you're just doing that infinite for loop. I don't know if you have anything to say about it. Maybe I just said everything there is to say about it.
Yeah, so this, every time you call accept, it gives you another connection.
Yeah,
And so that's why we're in a for loop, so we can handle the next connection
yeah.
back and forth.
So why didn't you put the listen? It seems like I guess you want every new connection and every time.
Listen creates a listener.
Okay, and that one
Accept
listener is
gives you the
listening.
next connection.
Okay, okay.
So you probably would not wrap this whole code in a for loop.
But you have line 48 through 54.
You have, the accept
That's
is in
the
the for
part you
loop.
want. That's kind of the listener, right?
Yeah, so to think of this as, I create the listener. If that fails, our program dies.
Yeah,
Then I accept the next connection and I go handle it.
yeah,
And up here, I might, and I'm not doing this. What I'm doing is I'm just reading one request and then writing one response.
yeah.
But normally you'd probably have this whole thing inside of here, inside of the for loop, because you can handle multiple requests.
Okay.
Like when I go to my browser and I go to a web page and I click a link, it's the same server, it reuses the underlying TCP connection.
Yeah,
Because actually establishing a connection is kind of expensive. So it's more efficient to keep one open and use it over and over and over. So all the HTTP requests to the server might go over the one connection. And that's why normally you do four. Now one at a time, it does one request at a time, but you have the first request and the second request. So we're reading request here, writing response here. Okay. Does that make sense?
uh-huh.
So we just need to change this so that this body is dynamic based on the URL you pass in. And I think we said it when I was writing the thing up here.
Yeah.